These examples go with lesson 10.1, the ellipse. Example 1, graph the ellipse. Identify the center, vertices, minor axis endpoints, and foci. Okay, before we graph this, we're going to have to actually know what all these different points are anyway. We'll start with the center. And the center of our ellipse is going to come out of the numerator here. And it looks like our center is going to be at 0, 0. The vertices, these are going to be along the major axis. And since the larger of our two numbers, 9's bigger than 4, is located under the x, that means our horizontal axis is going to be the major axis. In this case. All right. We also know that the major axis is going to be 2 times a, the length of the major axis, and a is going to be the square root of 9, that's going to be 3, and b, which is going to be on our minor axis, or in this case the vertical axis, is going to be the square root of 4, or 2. When we find the vertices, we're supposed to take the x-coordinate and we're supposed to add a and subtract a. So my vertices will be located at 0, minus 3, and 0, and also 0, plus 3, and 0. That puts my vertices at negative 3, 0, and positive 3, 0. All right, let's graph what we have. Let's see, negative 3, 0 is going to be right here. Positive 3, 0 is going to be right here. And of course, the center right here. All right, our minor axis endpoints. Because the minor axis is the vertical axis, we're going to add our b to the y-coordinate of our center. And in this case, we're going to have 0 and 0 minus 2, and the other endpoint will be at 0 and 0 plus 2, or 0, negative 2, and 0, positive 2. So let's plot those. 0, negative 2 belongs here. 0, positive 2 belongs here. And now we actually have enough information to draw our ellipse in here. The foci are not important when it comes to sketching our ellipse in there. So we can actually go ahead and just sketch this in. Be sure that you have nice, pretty rounded corners when you are drawing this thing in here. It should be more or less football shaped. I know that's kind of wobbly there, but this is a sketch of an ellipse. Okay, to find the foci, we need to figure out what C is. Now C is defined, or C squared is defined to be A squared minus B squared. And in this case, we said that A was the square root of 9. That means A squared is 9. So in our case, we're looking at 9 minus, and then B squared is going to be our 4. So our C squared is 5. That means that C is going to be the square root of 5. And the square root of 5 is a little bit more than 2. And so our foci are going to fall on our horizontal axis because they're always on the major axis, and it's horizontal this time. And what we're going to do is we're going to take the center and we're going to subtract off the foci. And then the other one's going to be the center plus the C. And so our foci are located at negative square root 5 and 0, and positive square root 5 and 0. And if we graph those, they're going to go somewhere in here between 2 and 3, and somewhere in here between negative 2 and negative 3. And there's our ellipse. Example 2, graph the ellipse, identify the center, the vertices, the minor axis endpoints, and the foci. All right, we need to get this into standard form, and the first thing we need to do is we need to make sure that it's actually equal to 1. So let's divide everything by 900 so we can have our ellipse in standard form. Now, this fraction over here is going to reduce. It does reduce into x squared divided by 36. And then my next fraction under the y is going to reduce also. This is going to be y squared divided by 100. And this time, because 100 is bigger than 36, our major axis is going to be vertical. And that's where we're going to have to graph our foci and where we're going to have to graph our endpoints. Or not the endpoints, I'm sorry, the vertices. The endpoints will go on the x-axis. Okay, let's see. A is going to be equal to the square root of 100, or 10. B is going to be equal to the square root of 36, or 6. And so we need the center to start off with, don't we? Well, once again, the center is going to come right here out of the numerator, and it looks like once again we're at a center of 0, 0. So we can go ahead and graph that in there. All right, the vertices. Now remember, this time we're adding to the y-axis. So A we said was 10, so the vertices will be located at 0, 0 minus 10, and 0, 0 plus 10, which gives us the point 0, negative 10, and 0, positive 10. And 2, 3, 4, 5, 6, 7. I don't have enough room on here, so I'm going to let each line represent 2 spaces. So 2, 4, 6, 8, 10. One's going to go right here. And 2, 4, 6, 8, 10. One of them's going to go right here. The endpoints, these are going to be on the x-axis, and we said b was equal to 6. My endpoints will be at 0, minus 6, and 0, and 0, plus 6, and 0, which gives us the points negative 6, 0, and positive 6, 0. So 2, 4, 6, that puts us right here. 2, 4, 6, that puts us right here. And now, again, we have enough information. We can actually sketch in the ellipse. And remember, it is supposed to look like an oval, kind of football shaped. Make sure everything's rounded off. It's not very round right there, but there's our ellipse. Okay, to get the foci, remember c squared is equal to a squared, which we said was 100, minus b squared, which we said was equal to 36. In this case, that's going to give us 64. C is going to be the square root of 64, but that's a nice number. That's actually 8. And so our foci, which are located on our major axis, the y-axis, will be located at 0, 0 minus 8, and 0, 0 plus 8, or 0, negative 8, and 0, positive 8. So 2, 4, 6, 8, that puts one of our foci here. 2, 4, 6, 8, the other one it's going to put right here. And there's our ellipse. Example 3, graph the ellipse and identify the center, vertices, foci, and the endpoints of the minor axis. Okay, this one actually will not have a center at 0, 0. The center of this one actually has moved. Now remember, it comes out of the numerator here. And the center is going to be located at negative 1 and positive 2. Negative 1, positive 2. So we're doing the opposite of what we have in the parentheses here. Negative 1, positive 2 gives me a center right here. The a, 25 is bigger than 9, so a squared is going to be 25. So if a squared is 25, then a is going to be equal to 5. And b squared is going to be equal to 9, so b is going to be equal to 3. All right. We need to have the vertices. Now the vertices are going to occur on the major axis. And since 25 is bigger than 9, the major axis is going to be horizontal this time. And our vertices are going to be located at -1, -5. Remember, we're supposed to subtract off a, +2, and -1 plus 5, +2. So these points are going to be -6, +2, and also +4, +2. So let's graph those. -6, +2 is going to put us right here. +4, +2 is going to put us right here. Okay, let's see. Let's get the endpoints before we do the foci. All right, the endpoints, our b coordinate is going to be 3. This gets added and subtracted to the y coordinate of our center. So our endpoints are going to be at -1 and 2 -3, and -1 and 2 plus 3. This gives me the point -1, -1, and -1, +5. Right, let's graph those. -1, -1 is right here. No, it's not. That's -1, +1. Sorry. -1, -1 is right here. And -1, +5 is right here. Okay. Let's get rid of that extra point right there. We don't need that. There we go. All right, now for foci. If c squared is equal to a squared minus b squared, then our c squared is going to be equal to 25 minus 9. And that's going to give me 16. And so that means c is going to be equal to 4. Now remember, our foci go on our major axis. And the center is -1, 2. So we're going to have -1 minus 4 and +2. And we'll have -1 plus 4 and +2. So the foci will go at -5, +2, and also +3, +2. One of them will go right here. And one of them will go right here. And then we'll just sketch in our graph as best we can, making this a nice little round shape here. And there's our ellipse, such as it is. Example 4, given 2x squared plus 11y squared minus 12x plus 44y plus 40 is equal to 0. Part A, write the equation of the ellipse in standard form. And Part B, identify the center, vertices, foci, and endpoints of the minor axis. Okay, what I'm going to do is I'm going to rewrite this equation, and I'm going to group all my x's together. I'm going to group all my y's together, and I am going to move that 40 over to the other side. Okay, so let's take a look at what that's going to look like. All right, and here is what I have. I have 2x squared minus 12x in parentheses, plus 11y squared plus 44y in parentheses, and this is now equal to -40. Okay, we're going to put this into standard form so that we'll be able to pick out the center of our ellipse. But the process for doing that is something called completing the square, and we did that back in Math 171. So here's a crash course on how to do it again, because Before we only had to do it with one variable at the time, but now I have two variables in my problem, and I'm actually going to have to complete the square twice on this. And I'm going to do both of them at the same time. All right, the first thing we want to do is we want to make sure that the coordinate right here is a 1. And since it's a 2, I'm going to pull out the greatest common factor, which is a 2. This is going to leave me with 2 times x squared minus 6x. And I actually need to do the same thing over here in this parentheses. So the GCF over here is going to be 11. And we're left with y squared plus 4y. And this is still going to be equal to negative 40. Okay. Now, the next thing I'm going to do is I am actually going to add something to both sides of my equation. Right here. Right here. Right here. And right here, because I can't add something on one side of the equation without adding it to the other, because I do have the equals there. All right, now the way I decide what goes in each of these spots. All right, let's look at this first one. We take a look at our middle term here, negative 6. All right, I'm going to take half of that. And once I have that answer, I'm going to square it. So half of 6, this is negative 3. And negative 3 squared is going to give me a positive 9. So I'm actually going to add 9 right here. But be careful, because I'm not adding 9 over here. I'm actually going to add 2 times 9. And that's because of the 2 that I had to factor out of the parentheses. And the 9 is now inside the parentheses. We're going to do the same thing in the second parentheses. I'm looking at my middle term, 4. I'm going to take half of that. And whatever I get, I'm going to square it. So half of 4 is 2, and 2 squared is going to give me 4. That's what I'm going to add right here, but be careful, I'm not just adding 4 over here, I'm actually going to be adding 11 times 4 because of this 11 on the outside and the 4 being on the parentheses right here. Okay, let's clean this up a little bit. We've set this up on purpose so that this parentheses right here will factor, and it does factor to x minus 3 times x minus 3. We wanted it to factor so that I had exactly the same parentheses. The other one's going to factor into y plus 2 and y plus 2. And then on the other side, we're going to add negative 40 plus 2 times 9 plus 11 times 4, and that's going to give me 22. All right, let's clean this up a little bit more. I can actually write this as 2 times x minus 3 squared plus 11 times y plus 2 squared. This is equal to 22. And remember, I said in order to be in standard form, our ellipse has to be equal to 1. Ours is equal to 22. So let's divide everything by 22. This fraction right here will reduce. We'll have x minus 3 squared over 11. This fraction right here will reduce, so we'll have y plus 2 squared over 2. And over here, we're going to have a 1. We wanted the 1 to be there. So this is the equation of our ellipse. And part A is now complete. Now, part B, this is doing what we just did on the previous 3 examples. We want to find the center, the vertices, the foci, and the endpoints. The only thing we don't have to do this time is graph it. All right, the center. Let's just go ahead and make some room right here. The center comes right here out of the numerator. We've got a positive 3 and a negative 2. The major axis is going to be horizontal, and I know this because 11 is actually bigger than 2. Okay. The vertices, these are going to be a little bit strange looking because we're going to have some radicals in there. Let's see. If a squared is equal to 11, a is going to be equal to the square root of 11. And if b squared is going to be equal to 2, then b is going to be equal to the square root of 2. All right, my a gets added and subtracted from the x-coordinate of my center, so my vertices will be located at 3 minus the square root of 11 and negative 2, and 3 plus the square root of 11 and negative 2. And if you want, you can go ahead and combine those, but I'm going to leave them here because they're currently in exact form and I can't do anything else to simplify them. And if you do combine them, you're only going to get an approximation there. All right, the endpoints. This is the b. It's going to get combined with the y-coordinate of my center. So the endpoints will be located at positive 3, negative 2 minus the square root of 2, and positive 3, negative 2 plus the square root of 2. All right, and we'll get the foci, but before we do, c squared, remember, is a squared minus b squared. So in this case, we're looking at 11 minus 2, which is 9, and that means that c is going to be equal to 3. So our foci, our c-coordinate gets added and subtracted to the x-coordinate of the center. We'll have 3 minus 3 and negative 2, and 3 plus 3, negative 2. So our foci will be located at 0, negative 2, and 6, negative 2. Example 5. Determine the standard form of an equation of an ellipse with vertices at positive 3, positive 3, negative 3, positive 3, and the foci 2 times the square root of 2, positive 3, negative 2 times the square root of 2, positive 3. Okay, let's graph this. What we do know, we've got vertices at positive 3, and negative 3, positive 3. And the foci are located at 2 times the square root of 2. Let's see what that number is. This gives me 2.8 and negative 2.8. So positive 2.8, positive 3. So that's going to put us right here really close to that endpoint. And the other one's going to be really close right here to the endpoint. Okay, so remember our foci belong on our major axis. Okay, the center of our ellipse should be exactly halfway in between the endpoints. And if my endpoints are located between here and here, that means the center should be located right here. This is exactly halfway in between, because to go 3 to the left will put me on this endpoint, and to go 3 to the right will put me on this endpoint. So right away, I know that the center of this thing is going to be at 0 and positive 3. Okay. Now, since I know that the center is at 0 and positive 3, and I know that the foci are the equations, let's see, it's 0 minus c, and in this case it'll be 3, and 0 plus c, and in this case it's going to be 3. Well, 0 minus c, that's just negative 2 times the square root of 2. And 0 plus c, that's just going to be positive 2 times the square root of 2. If negative c is equal to negative 2 times the square root of 2, then positive c is going to be equal to positive 2 times the square root of 2. There we go. All right, that's what I need. Now, what is c squared? Well, c squared will be 2 times the square root of 2 squared, and that's going to give me 8. Okay, now the major axis, once again, is horizontal, and we know this because the foci are located on the horizontal axis. They're located horizontally this way. Okay, that means we can now figure out what A is. A is equal to 3, which means that A squared is going to be equal to 9. Okay, now we have enough information to figure out what B is going to be. Because remember, C squared is equal to A squared minus B squared. Well, we know C squared, we just found it. We know A squared, we just found it. If we subtract the 9 over here, we're going to have -1 equal to negative B squared, which means that B squared is going to be equal to 1, and B is going to be equal to 1 as well, or the square root of 1, which is 1. Okay, I think we have enough information to write our equation now. We'll have x minus 0 squared, or you can just write that as x squared, over A squared, which is 9, plus y minus 3 squared over B squared, which we just found to be 1. And then this is going to be equal to 1. So here's the equation of the ellipse described by the information up here.